Unit 4, Lesson 4. So dealing with scientific notation. Scientific notation is best used for really large numbers or really small numbers, okay, which we already kind of know. Okay, so the distance from the Earth to the Sun is approximately 93 million miles. The speed of light is approximately 300 million meters a second. The number of molecules of gas per cubic meter is approximately something I don't know. In terms of
how many zeros?
3, 6, 9, 12, 15, 18 zeros. Oh, thanks, Googler. Okay. All right. So all these large numbers are written in standard decimal notation, and it would be easy when writing them out with scientific notation. So that's what scientific notation can help us with. Okay. All right. And I haven't clicked right yet. Clicked nothing right. Oh, good. Hey, good. Perfect. Okay. All right. So example 1 says complete the following table, standard notation. So we always want to have standard notation, remember, to 1 decimal. Okay. So 1 number, 1 decimal. So we want 6.15. Okay. And then you're going to figure out how many tens are in that. Okay. Well, tens every movement. So 1, 2, 3, 4. So it'd be times 10 times 10 times 10. That's written in, that's expanded, and then we'd write it for scientific notation as 10 to the 4th. Okay, for this one, 5. 1, 2, 3, 4, 5 with 5 tens. One, 2, 3, 4, 5. So it'd be 5 times 10 to the 5th. 46.3, we write as 4.63 times 10. So just 10 to the 1. Okay, now it's giving us the middle one. It wants us to figure out what that is. Okay, so if I times that by 2 tens, that moves it over 2 spots. So it'd be 281, or 2.81 times 10 squared. And you kind of, hopefully they do this to get you guys in the idea of that the number of zeros is the number of tens. Okay, so we have 1, 2, 3, 4, 5. So 7 with 5 zeros. So we have 700,000. Okay, which is the same thing as 7 times 10 to the 5th. 9.2 times 10 squared. So that'd be 9.2 times 10 times 10, which would be 920. And lastly, the biggest one, 1.4 times 10 to the 6th. So we're going to have 1.4 here for expanded with 10, or 6 tens, excuse me. Okay, and that would also be, if we write it all the way out, that would be 1.4, so 1 with 5 zeros. 1, 2, 3, 4, 5. 1.4 million. Okay, very good, very good. Okay, so, for example, 2, include the following statements from the top of this page using scientific notation. The distance from the Earth to the Sun is approximately what in terms of scientific notation? 9.3 times 10 to the 7th. Good. The speed of light is approximately 3 times 10 to the 8th. Good. Oh, well, thank you. Quintillion. Quintillion. You're just you and Google are just a wealth of knowledge.
Yeah, actually solved my brain.
Oh, I figured that. Okay, the number of molecules of gas per cubic meter is approximately 2.7 to the, what is it? 19th. Good job, Chris.
Wait, yeah.
2 to the quintillion. Oh, learn something every day.
Right now, Chris.
Right now. You could be a scientist of gas. Who knows?
Yeah, we just.
I don't like this. I need to get this fixed so I don't have to do it so small. Because I'm scared I'm going to jump a page and go back. Okay. Don't laugh at me. Okay. All right. So example 3: convert the following numbers from scientific notation to standard form, or standard notation. Excuse me. Standard form's Math 20. Standard notation. So we are going to write them out. So 10 to the 7th. So the way I always think about it is, if there's a number there, I'm moving over one spot, so it's a -1. So it's be 3.8 with 6 zeros. So what I'm saying is 1, 2, 3. So it's 38 million. 3.8 times 10 to the 7th, 38 million. 2.51 to the 12th. So I'm going to move over 2 spots and then add 10 zeros, because that's how many's left in terms of spots. So 2, 5, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It's probably up in the quintillions somewhere. Okay. And then 2.9 times 10 cubed. Move it over 1 plus 2 zeros. 2,900. Simplify and write scientific notation. So the best way to think about this is to me, is use your exponent laws. 1,000 is what? 10 is a 3. 10.2 and 10.3 is 10.5. That's the best way to think of that, in my opinion. Same thing on part B. Part B is 10 to the 7th and 10 to the 1, which makes it 10 to the 8th. And if 1,000 is on the bottom, what are you going to do with the exponents? Subtract. So we have 5 times 10 to the 6 over 10.3. 6 minus 3 is 3, so 5 times 10 to the 3 is your simplified answer. Okay, so scientific notation, as we're talking about right now, is used for really large numbers, and it's also used for really small numbers, okay? So let's get to the really small numbers now. And when you're doing small numbers, you're moving your decimal place the other way, which means what kind of exponents? Negative. Am I going too fast? Oh. Yeah, it's a lot. Oh, geez. Look what you started. Okay, an inch is about 0.000025 kilometers. Okay, and I won't say all the zeros here, but the mass of a particle of dust is about 9 zeros and a 7.5 of a kilogram. The mass of an electron, so very light, obviously, is 3, 6, 9, 12, 15. What you got already? 27 and a 9 grams. Okay, 27 zeros and a 9. All these small numbers are written in standard decimal notation, and again, it would be easy to write them out if we had scientific notation. So let's go and do our table, and then we're going to do the same thing, writing out those from the beginning, so don't forget those numbers there. All right, let's do this chart here. All right, so we want to move this 1, 2, 3, 4 places, so 5.3 times. Now, is it, where we, in expanded form, how are we going to write it? Yeah, it's going to be over the top, or 1/10. That's the other way you can write it, okay? So we're going to do that for this case. How many times did I say? 5? 4. Which is the same thing as 10 to the negative 4. Or, like Chris said, we can write them over the top. So we can also write it as 7, 1, 2, 3, 4, 5, 6, 7, 8, over 8 tens. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And that would be same thing as 7 times 10 to the negative 8. All right, this one here, 2.9. So that would be, we move it over 3 spots, so it would have 2 zeros in front, 0.0029. Same thing as 2.9 times 10 to the negative 3. 7.1, we have 6. 1, 2, 3, 4, 5, 6. So it will be 5 zeros, 1, 2, 3, 4, 5, 7, 1. Or 7.1 times 10 to the negative 6. Okay, this one here, 3.1 times 10 to the negative 3. So that would be 3.1 over 3 tenths. Or move it over 3 spots, 0.0031. Okay, and the last one would be 8.5 over 5 tenths. Okay, or moving it over 5 spots, which give me 4 zeros. Very good. Okay. All right, so now we'll convert those super long ones from earlier. Okay, example number 6. So complete the following. So the inch is about how many kilometers? 2.54, which we recognize that, right? Because there's 2.54 centimeters in an inch. Okay, times 10 to the what? Negative 5. Okay, how about the particle of dust? Anybody get that? 7.5. Yep, it was negative 10. Good. And the mass of an electron is 9 times 10 to the negative 28. Very well done. Explain why 0.4 times 10 to the negative 8 is not written in scientific notation. Why is that not in scientific notation? We always want to have at least one spot in front of the decimal. It should be 4 point. Okay, so we want this. We need to move that over 1. Okay, so we want to have a whole number, or the way they describe it is or have something between 1 and 10. You want to use scientific notation with numbers between 1 and 10. Between 1 and 10. Okay. So then write 0.4 in scientific notation. So I'd move it over 1. So I'd make it a 4. So would that make it negative 9 or negative 7? Negative 9. We're moving to the right. So what's the opposite of the right? I'd have to take a left off. I'd have to go to left 1 to balance that out. Okay. Now you don't have your calculator, so we're going to go through just stuff with your calculator now. Okay, using psi mode in your calculator. Okay, the psi mode of a graphing calculator may be used to express numbers in scientific notation. Okay, it's up here. You have normal, psi, and then I think that's, what's E and G first? Oh, I forgot. I forget what that's for. I'll let you guys know later. But it'll just demonstrate them like this. E9 means that it's going to be 9 zeros added on, or 10 to the 9. Okay? So, anyways, that's how you do it. So mode, click over to psi, hit enter, and then you can put stuff in your calculator. So if you entered this number here in your calculator, 4506 with 6 zeros, hit enter, you'll see it'll give you E9, which gives you in scientific notation. So how that is in scientific notation is, to us, this means 4.506 times 10 to the 9th. So right here. Okay, questions on that? You want to use mine? Okay, to convert back to standard notation, you would just go back to your standard form. Okay, make sure it's in normal mode. and then you could put 4.506 times 10 to the 9th. So if you want scientific, got to put in scientific, and it'll give you this type of reading here. Okay, and if you want regular, standard notation, you would just make sure you're in normal, and you could put it in, and it'll highlight that as well. Okay. All right, last page here. Any questions on the calculator? Everybody get that okay? All 7 of us? All right, so using the EE feature. Okay, so the EE feature represents a 10 to the n. Okay, so that is like scientific notation. It's kind of setting it up for you. This feature may be useful in saving time. So, for example, use the following procedure to write down the product of 4.25 times 10 to the 6th times 3.65 times 10 to the negative 4th in scientific notation and standard notation. Okay, so in the calculator, put in scientific mode. Okay, and you're going to put, so it's kind of letting us put scientific notation in our calculator. So access the EE feature by pressing second, and then it's the comma, it looks like. Everybody see that? Yeah? No? Yeah? Silence means yes. Okay, so then it'll display an E. So you have 4.25 second, comma, 6. So that means E6. That's 10 to the 6th. So that's what this piece is. Okay, and you go times 3.65 times E negative 4, which is 10 to the negative 4. Okay, and then your calculator will punch out your answer, which is 1.55125, 10 to the 3rd. Okay, and that's what's right here. Any questions on the EE thing? To be honest with you, I haven't really used that much. So it's second, comma.
Yeah, I got it.
Everybody's got it? Okay. Uh-oh. What'd you do? Let me see. Oh, there's an E in the front. There you go. You just have to see that E's in the front there. You don't want the E in the front. Okay. Everybody good? Okay. Let's continue. Finish this thing up here. So 3, to give the answer in standard notation, you just take it off standard. Just take it from normal to standard. Or excuse me, from sci to normal. All right. Use calculator 2. So go ahead and try this here. Your last example of the day. Okay, so write the product 3.5 times 10 to the 5th times 2.6 times 10 to the 9th in scientific notation. Okay, so again, your calculator should look like 3.5 E5 times 2.6 E9. Okay, and that should give you 9.1 times 10 to the 14, which in your calculator will say E14. Okay, you can do the same thing here. Okay, I would probably use brackets here. Whenever you're in division bars, I like to use brackets to make sure things don't go haywire. So brackets 7.5 E negative 17 divided by 5 times E, you don't have to put times, sorry, E negative 9. That's how I put that one in your calculator. You should get 1.5 times 10 to the negative 8. Okay? And that's it for lesson 4. So we can take some questions here if we have any.